Hi there. So here we are. We should have enjoyed this part of a practical workshop together, but unfortunately because of this COVID situation I will be the only one playing with these toys, let's say, and I hope to show you something interesting in terms of specification we must fulfill for being compliant, full compliant, let's say, with the CISP 16-1-1 standard. So I've prepared a table here on in the background that we will see in a while, and we have here three equipment. One is a full compliant receiver that is also FFT based. Then we have a pre-compliant receiver, but maybe better to call it compliant. Let's say it's not full, but is very close to the compliant one. And then we have a very good spectrum analyzer that is also equipped with the EMC function. But the difference is that both this spectrum analyzer and this pre-compliant receiver, let's say, is are not equipped with preselector filters, while of course the full compliant one is having the preselectors. So as we have discussed before about the importance, the relevance of the preselection, this kind of practical demonstration is very helpful to show how this is acting in reality on these different units. To show this, we will use a pulse generator that is exactly providing us all the pulses that we need to perform this kind of test. You can see here we can select the band. We will use the band B for Q-peak detection, and of course we will use both the pulses and the carrier wave to show how these are measuring. So that's meaning with the carrier wave we can start just checking about the signal that we are able to measure, and we will use the frequency that is 29.49 MHz, so it's very close to the end of the B band. In this case we better use the attenuation for only the carrier wave by 20 dB, so we can stay in the range of the spectrum analyzer that is having a maximum level of 100 dB microvolt it can measure. So let's just try to check about this carrier wave, but before starting I would like also to tell you something about this table. You can see in the table we have a column here where we will use this 80 dB microvolt, while the reference should be 66 for the carrier wave, and of course the reference for us will be the 60 dB microvolt that we should read for the 100 Hz pulse repetition frequency, something that we can find in the table from the CISP standard. So this is the reference, so that's meaning here we should measure 60 dB microvolt without any offset, let's say. When we go down to 20, 10, 2, 1 and the single pulse, all these values are representing the difference with respect to the reference level. So that's meaning if the reference will be 60, for the 20 Hz we will have 60 minus 6.5 dB. And this is something that we are going to check and measure with all the three equipments. So let's start just checking about the carrier wave. I've already set the receiver at 29.49 MHz, so I just connect this to the input of the receiver, and we are using attenuation 0. Of course the automatic attenuation is always available, and we are using 9 kHz filters, RBW filter, and 1 second hold time. So you see here we have 80 dB microvolt, almost, let's say 79.88, so that's meaning 80 for this case. on the full compliant receiver. Of course, this should be the same in the other receivers. So let's say here, because this receiver is not having its own display but is connected through USB to the PC, we have the panel there that we use to perform the measurement. The frequency is always the same, of course, and we see here we have 79.55, so we can say 80. So just write down 80 here. And here for the spectrum analyzer as well, we can measure, but of course we are using the span zero function. So with span zero function, this meaning is a kind of manual mode. We tune just at frequency and we measure it. And this is the only way we have for measuring the quasi-peak with this spectrum analyzer, because it's equipped with EMC functions, so that's meaning with the RBW filter, 9 kHz, and also the detector. But we cannot run it in a continuous mode with the quasi-peak. The measurement for quasi-peak we can only get on some points when we perform the sweep. So in this case we have 79.37, so just write down there 79, just to take a note about that. Okay, now we move back to the full compliant receiver, and we are going to set now, first of all, we delete the carrier wave, so we set the carrier wave off. Then we go to the pulses and we start measuring the 100 Hz pulse repetition frequency. So you see here is 100 Hz, and on the receiver we can read exactly 59.58, so is 60. Let's say 60. Then we can reduce this value to 20 Hz pulse repetition frequency, and we can read 53. We go down and we read for 10 Hz 49.5, let's say. We can keep it. Then we can go down to 2 Hz, and 2 Hz is 39, almost 40, let's say 40 dB microvolt. Then we go to 1 Hz, and 1 Hz we have 37.37, so that's meaning 37, let's say. For the single pulse is a different deal, so we will check it about it later. Now you can see here what I was telling you before. If we consider this is the reference is 60, then 53 is almost 60 again if we add the 6.5 offset. And the same here is almost 50 plus 10 is 60, and here 40 plus 20 60, 37 plus about 23 is again 60. So that's meaning this is of course fulfilling the specs from the SIP standard. We can also perform this measurement with the preselector off. So we just deselect the preselector here, is off now, and we perform the measurement again, starting from the 100 Hz. So 100 Hz now is almost the same, 60. Okay, now we go down and is 20, so is 53. Then we go down again, 10 Hz we have 50 something, 50. Then we go down, 2 Hz is 41. Down to 1 Hz is 40. So that's meaning here we have a very small difference just when we go down below 10 Hz. We start feeling a deviation. Now we can check what's happening with the other units. So we move to the one in the middle. So with this let's say less compliant receiver, we have for 1 Hertz we can read 42 something, 42.5. So here is 42.5. Then we go up to 2 Hertz. 2 Hertz we read almost 43. 43. Then up 10 Hertz we can read almost 48, let's say 48. Then 20 Hertz we have a 52. And last one, 100 Hertz we have 58. Okay, so you see here the difference is of course higher than with the other receiver, because also the let's say the filtering that we have here somehow is not pre-filtering, let's say, is not full compliant like in the other case, but we still have quite a good result, just a small deviation here. Now we move and we check the same with this guy, the spectrum analyzer, and we can measure starting from 100 Hertz. 100 Hertz now is giving us 25, almost 26. We go down to 20 Hertz and we measure 18 point something. Then we go down, we have 10 Hertz and we have 17 almost. Then we go down again to 2 Hertz and we measure 16. Down again, and we have for 1 Hertz we have still the same, 16. So it's just going in the range of the minimum sensitivity. You can see almost the same value. So here, what's happening? You can see the deviation is very, very high with respect to the other values that we have measured with the receiver. And this is exactly the demonstration of missing an attenuator that is possible to adjust frequency by frequency like in a receiver, because the receiver is tuning that frequency and is adjusting the attenuator based on that one, while the input of the spectrum analyzer is wideband and the attenuator is only one to adjust the whole contribution of the signal we are getting at the input. Of course, measuring then in that point, and that's the fact. We can also perform another test, so we can reduce the amplitude by 6 dB, and we can see about the sensitivity. But first, before doing that, we have to check the single pulse that we left behind us. So for the single pulse, we need to set a hold time that should be much higher than 1 second. The standard is saying you can use up to 15 seconds. So let's say already with maybe 6 seconds we can measure something. So if we change the hold time and we set exactly 6 seconds, then we turn back again the selector, we can leave it off, then we will use also the on one. So we can apply the single pulse. For the single pulse we need to push the button and we will get it as soon as we are catching the signal. We already have there something, it's almost 40, so just we can push it sometime more, because depending on when this pulse is occurring, and then we need to wait for the whole time for the quasi-peak detector to charge and to measure, then we can read what's happening. You see now we cannot see that immediately, now is there. So we keep pushing some time just to keep the level constant, and you see it's 40 about, so we can write it here 40. For this, with the preselector on, level preselector on, then we can repeat the measurement and we will see a slight difference in this case. Yes, 37, so it's 37. Exactly 37 plus 223 is again 60. And that's exactly what we expect. If we do the same with the other receiver that is not having preselector filters, we can see what about the difference. We can set here 6 seconds and then provide the pulse. So let's try and catch the pulse. It should come sooner or later. Yeah, maybe, okay, there it is. Now we will see the quasi-peak appearing is 42, almost 43. So we can write it here 43. And unfortunately, in this case, we cannot perform this test because you see here for the quasi-peak detector, so this is a quasi-peak, and for the quasi-peak detector it's not possible to set this hold time higher than 1 second. So this is a kind of test we cannot perform with this spectrum analyzer. Then, as I said before, we can try to set the attenuation lower than let's say 60 dB lower than before on all the pulses, and we can see what's going on. So if we start back again with the pulse, let's say, let's move to the 100 Hertz, okay, then we go to the full compliant receiver, reset the time, the hold time to 1 second, okay. And now we can see here the preselector is on, we have a 53.5 in this case. Yeah, 53.5. 20 Hertz is, we are reading 47. For 10 Hertz we are reading 44 about. For 2 Hertz we have a 35 or 33, sorry. Then for 1 Hertz we have 31 point something. Yeah, let's say 31.5. Okay, if we use a preselector off, then you can see. Now let's start back again from 100 Hertz. It's more comfortable. Is 53.5. Then 47. Then go down to 10 Hertz is 45, 43, 44. Then we go to 2 Hertz is 35, and down again is 30, almost 35 again. So what's happening here? You see preselector on and off is not having a so big difference, and the sensitivity is still quite good with respect to the values we measured before. If we do that with the one in the middle, we can see that this is showing some differences. So let's start from 1 Hertz, 100 Hertz. So 100 Hertz, just resetting to 1 second, and 1 second maximum all time. So we will see that is 52. We go down and we read 45, 46, 46. Then we go down again 10 Hertz and we read 42. Again down to 2 Hertz. We have 35, and down one more to 1 Hertz. We can read 35. Oh, sorry, I changed this one. Here, 35. Okay, so here you see also the deviation is not so big with respect to the situation we have here. If we use the other guy, the last guy, we repeat the test, and now we will see what's going on. So for 100 Hertz is 32. Sorry, I have two hands, but to let you see is quite complicated. Okay, so to 20 Hertz we have 24, about. We go down to 10 Hertz, we have 19. Go down, we have 17. And down again, we can read again 17. So now we have checked from the table that the levels that we have here, both without the attenuation and with the 6 dB attenuation with respect to the reference level, is being affected in a relevant way when we use the spectrum analyzer, even if it's having a receiving function. Just because this is almost hidden in the background noise. You know, we saw that as higher as the noise spread over the band, we can have, of course, a maximum level that we can measure, and this is exactly going in the noise level that is spreading there. So just to compare, okay, with the other data, we can consider that from the table in the standard we have this tolerance, so it's plus or minus 2 dB from the single pulse to the 1 Hertz and 2 Hertz, then it's becoming 10. 10 Hertz is having a 1.5 dB tolerance, and plus or minus 1 for 20, and of course 0 for 100 Hertz, that is the reference, and so on. So this is exactly what we have measured here. So this is, let's say, just to clearly show about the effect of having some filters or using receiving functions, like in this case, because the receiver, even if pre-compliant, is providing better results and very close to the full compliant one. Then we can now change to a real test with a sample. UT is a food mixer, just to quickly show what's going on when we take a measurement with this. We can use this software that is connected to the full compliant and the pre-compliant receiver. Both are using the same, and we can perform a test here. I already prepared this test between 150 kHz to 30 MHz, so band B, with all the parameters of the band B, and the detector, of course, we select just a peak and Q-peak, using just one limit, the limit for SIS22 B quasi-peak. Then we can consider here the preselector is now on, so this is the real full compliant condition, and we can just execute the test in this case. So let's start it. We execute it. Okay, we don't want, we want a new one, so I'm pushing the button on this to generate some noise. You can see here, this FFT receiver is very fast, of course, so it's completing the test in a short time, almost 22 seconds, with 1 second all time. But with the other receivers, we will see we cannot perform the same, because otherwise we will take a very, very long time, and we don't take this now. So now I would like also to perform a second test using the settings without preselection. So we go for testing without preselection filter. You can see here off, the other parameters are exactly the same, and we can repeat it. So we push execute. Of course, we wanted to have a new one. And it's looking almost similar, because the behavior of the curve is very, very similar to the previous one, but we will check it in just a few seconds what's going on when we compare this. So if we go to compare this curve, let's say just the quasi-peak, with the previous curve, the one with the preselector filter. So is here somewhere. Okay, this is the full compliant one. Let's say quasi-peak. Sorry, we want only the Q-peak. So if we compare both, you can see here we have a difference of about 5 dB in this area between one and the other. And of course, you can recognize here there is a difference where we can consider compliant this unit if we measure with the full compliant receiver, because it's below the limit line, while it's absolutely not compliant if we measure without the preselector filter, so like a pre-compliant receiver. We can repeat this test, maybe just using two portions of this. Let's say we can take about, let's use this, between 500, 600 kilohertz maybe, where the full compliant measurement is below the limit. We can see what's happening with the pre-compliant receiver. So we can go to the sweep, we can use the setting for pre-compliant receiver that I already prepared here by pre-compliant receiver. Of course, the pre-compliant receiver is having preselector off. Now we switch off the first one and we use the other one. Okay, so we take now some points from the graph that we have got with the full compliant receiver, and we go to measure what's happening with the pre-compliant one. So we connect this to the pre-compliant receiver, and we see what about the measurement, but in a shorter part of the spectrum, because otherwise we will take too much time with the 1 second whole time. So we go to measure, for example, in this range between 500 about and 600. So we can go to the sweep for this. Let's try to make by pre-compliant receiver. So we can change this 0.5 to 0.6, and then of course the preselector is off, and we start with 1 second all time. So just do it, execute. So we can already see what's going on. That the signal is a certain level below the limit, but then is going over. Okay, that's it. Now we can immediately compare this with the full compliant receiver in the same range. Just use the quasi-peak for this comparison. So we will get confused between the several cars, and we take the full compliant receiver here. Also in this case we avoid to look at the peak, and you see what's happening here. So in this case, in particular, we have a difference between full compliant and pre-compliant that is quite evident, right? So that's something that may be critical when evaluating the compliance of the UT. Now we can take another measurement, always by pre-compliant receiver, and have a look to another range. Let's see when the full compliant receiver is over the limit. For example, in this case we can go to check between 5 and 5.2 megahertz. Let's have a look. So we make another sweep by pre-compliant receiver. We make _1, for example, and 5 meg and 5.2. Okay, now we start the test. It's taking, of course, always a longer time with this pre-compliant receiver because it's not FFT, and we can see almost everywhere the signal is over the limit. Okay, now it's finished, and we can immediately compare this with the curve for the full compliant receiver. Look, now there is again a difference. The full compliant is below the limit and the pre-compliant is still over. Okay, now we can repeat the same kind of test with the spectrum analyzer. So we move this cable to the spectrum analyzer. We can connect it here. Okay, and to run this we will use its own software. It's a different one, of course, and we can use the setting, for example, let's see if already. Okay, this is 5 at 5.2 megahertz with 1 second all time and 9 kilohertz filter. Okay, we can start this test. So we can make a pre-measurement, because in this case it's not possible to test with the two detectors simultaneously. So we have the test made at first by the peak only, then some peaks are being identified or even manually selected, and then the quasi-peak will be performed only on those points. So let's do it. but on the screen we can see that. So it's almost 5.2, and this is becoming very hot. Okay, it's 5.2, so should be finished. Now it's taking some time to record the points, to store the points. Then we will get the chance for measuring the quasi-peak. So, let's see. Okay, now you see that there is a button here, remeasure, but first of all we go and check which is the peak identified, this one. Okay, now we can take a remeasurement on this, so just push remeasure. And we go to the point, 5.14 megahertz now, and performing the quasi-peak test. So it's been done already, so this point is here. And we can see also in this case, this is over the limit, so it's about 63.90. So 63.90, if we compare it with the other 2 points, 53.90 at, sorry, 5.14. Okay, we can see is somehow, let's say, here in this range, but it's even below the level of this quasi-peak detection. So it's looking that could be a better measurement, but let's see what's going on between 500 and 600. So we can change the measurement, make a new one. Okay, we save this. This is 5 and 5.2 meg. So we make another one from 500K to 600K. Okay, let's see. Say okay. Okay, make a pre-measure. Okay, that should be finished. It's 600 kilohertz now, and we can see already that this is higher, no, much higher than the limit. While, if I remember well, we saw this in the other case was below the limit for the full compliant receiver. Let's check about it. So we can remeasure this point. Let's do it. Remeasure. Okay, that's it. Here we are. So with the quasi-peak is again over the limit. So let's go and check what was happening for this point. We say it is 585. Okay, let's check it by full compliant receiver. Okay, here it is. 585 should be somewhere there. Yes, here. Let's say, and you can see is the quasi-peak is definitely below the limit line. And if we compare this with the pre-compliant, should be this one, maybe. Yes. And you see the pre-compliant one is a little closer to the limit with respect to the other. So definitely the behavior of this is better in this case than the spectrum analyzer. So we can conclude now that the only possibility to get let's say a reliable measurement is to have a unit that is satisfying as close as possible the CISP compliance for the pulses, the CISP pulses, and that's it. And we already saw what about that in our table, so I think this is clearly showing practically what about these differences. Then, I think this is all for this workshop. It would have been nicer to have you playing with me the units, but okay, maybe it will be a chance for the next time. I wish all of you a nice conference, and I remain always available for questions, even after this video. You can definitely ask or raise some questions, or otherwise you can do that by email or the other tools that the conference organization is making available for everybody. Thank you for listening, for watching, and I can say goodbye for this time.